Welcome to today's masterclass. My name is Jose Rivera, and I'm the CEO of CSIA, and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global, nonprofit trade association with over 500 member companies in 35 countries. To highlight just a few of CSIA's member benefits, the CSIA best practices guide system integrators in the setup and running of a solid company. These best practices reflect the knowledge gained by system integrators over the years and shared freely. Any system integrator can benefit from deploying the best practices, but gaining the CSIA certification is a confirmation by a third party that you have deployed them correctly. Maintaining a valid certification ensures that your company stays on a path of continuous improvement. For partner members, CSIA offers an ecosystem to grow their system integration programs, understand their customer pain points, monitor industry trends, and share their thought leadership. A trusted resource of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps system integrators, industry suppliers and manufacturers, and process companies connect and do business. That makes the exchange a first stop where end users can compare integrators, determine which products to use, and have questions answered by specialists in the field. For system integrators and partners, it provides a platform to increase your digital presence, support your content and search engine optimization marketing efforts, position your company and C-suites as thought leaders, showcase your expertise, and nurture prospects by providing a trusted, credible source for information about your company and its products. Finally, a reminder that in 2021, we will have increased access to knowledge sharing, community building, and networking throughout the year when you join or renew your CSIA membership. CSIA is committed to delivering extremely relevant content to system integrators while providing partner members access to a highly engaged audience. To that end, CSIA will deliver weekly virtual events on a broad range of topics and experiences, all of which are open to sponsorship. For more information, one more point. We have had this estimation course since the end of last year available. This is self-paced, web-based training put together by LATSA, which is a member of CSIA. Tom is the leader of LATSA. It's a training that has been taken by more than 40 participants, and we have received very good feedback. So without any further ado, I would like now to introduce Tom Sulda for his estimation course. Sorry, for his Agile presentation. Thank you. Tom?
Good morning, everybody. I think I'm sharing my screen now. Jose could confirm that you can see that correctly.
Yes, we can.
Very good. Well, I think it's around 10 o'clock in the morning where most of you are, I would think, if you're in North America, depending on what side of the country you're on. Over here in Adelaide in South Australia, it's around about, let me see, 1:34. So yes, it's a little bit early in the morning, but that's fine. So today we're going to be talking about Agile specifications. One of the things that's interesting about Agile is that its prevalence is becoming more and more, I guess, endemic around the place. System integrators have started to see it over the last couple of years, but I think it's been around for quite a long time. I myself am a certified trainer for Agile project management. You might see that little logo on the bottom left of the screen, which says APMG International, which provides Agile certifications. There's quite a few around. That's just one of them. Also, I'm a certified instructor for something called Agile BA, which is Agile Business Analysis as well. Okay, so what we're going to talk about today is just Agile in the sense of Agile specifications. I'm sure most of you would have heard of some of the terms that are getting around the place And you may be employing some agile techniques yourself, such as, using Scrum teams, working in increments, that type of thing, or agile estimation, or planning poker, all these types of things. We're not going to go into all of those terms today. We're really going to stick to using agile specifications, and where you might see them in a tender or an RFT or an RFQ, or whatever terminology you might come across. Just as another reminder as well, as I go along, please feel free to ask questions if you want to ask questions along the way, and I'll try and answer them as I go along as well. So if you've got an insight, just hit us with that insight and we'll see if we can sort you out pretty quickly. Okay. So why Agile in specifications? Well, Agile really was born out of IT environments. It's been around for quite a long time. And so most of the people that I've probably taught as Agile project managers or Agile business analysts over the last maybe 7 or 8 years, pretty much all out of IT environments. But because I'm involved with the CSIA as well, we see it's starting to creep in to our environments over the last couple of years. Why was it actually put in place? Well, it was to support this need for flexibility to create innovative yet robust software solutions. One of the things that's interesting about Agile is a lot of people think it's loose as a goose. We can just basically put solutions together and throw them out the door, with a little amounts of formality, but it is actually quite robust and rigorous in terms of like quality and testing. So that's probably a myth that needs to be busted about Agile if you've ever heard of that and haven't used it before. But significantly, IT and OT environments are now intrinsically connected. So we can have a PLC in the field connected to SCADA, connected to MES, and procurement and sales could be connected to it as well. So we could be driving our production out of, the sales application, for instance. So it's been pretty natural over the last, half a dozen years for the larger companies to blend their IT and OT environments, but also over the last couple of years, the impact of IoT has made that even more prevalent. For example, we worked with BHP, I think it was the year before last, and they had blended or merged their IT and their OT environments, and they did that for their whole technical team. So that was a very large project globally to train the IT and the OT people in all their types of methodologies that they were using, and especially Agile was one of the key ones that they wanted to start using across their IT and OT teams to create one technical team to use the same methodologies. Another thing is engineering graduates, whether they be computer science graduates, whether they be engineering graduates, they're most likely nowadays to have worked in, their projects at university in Agile teams or in Scrum teams to produce, their projects. So it could be a software project, it could be a mechanical engineering project, but they're more than likely to have been using Agile nowadays as well. So they're going to turn up on your door, or they're soon to, pretty soon anyway. And there's a lot of non-SI engineers coming out of purely IT environments, and you guys would probably be hiring them already anyway because of this merging of IT and OT. All right, so let's get into some Agile specification. Now, there's a couple of things that are interesting out of Agile, and one of those things is to be an Agile supplier or an Agile customer. And there's a rub between the two, I would say, or advantages to being an Agile customer. So for argument's sake, we here at LATSA when we actually specify things that we need to get built ourselves, we often use Agile specifications to do that. So what do I mean by that? So that means that we're being an Agile customer ourselves and we write Agile specifications. So for argument's sake, we needed an application written for mobile app. And what we did is that we specified using Agile specifications to get that. So why did we do that? Because this app hadn't been built yet. We had some ideas about what we wanted out of that app, but what we also wanted is that we wanted a fixed cost and a fixed time frame to get that application done. Which meant that we needed to be a little bit flexible about what we wanted and to give ourselves flexibility with our supplier to get that done. And so what did that mean? That meant we prioritized in this funny way, this funny acronym that we use in Agile, and it's called the Moscow method of prioritization. And in doing that, the customer accepts that they won't get everything they want, which is interesting. Because normally in the environments that we've worked in as system integrators in the past, we generally will want to give the customer everything that they want, but the customer often changes their mind, the goalposts change, and then we can be getting ourselves to a point where we're arguing commercially about who said what was specified, and whether or not that's been delivered or not. So Agile is attractive because it really tries to get away from the commercial side of things and works more towards a collaborative relationship with suppliers. So what do I mean by that? So in the case of this application that we were talking about earlier, or I was talking about earlier, we said there are certain things that were a must-have with our application. And so when we define that in an Agile specification, we're talking about something called the minimum user subset, which really means without this requirement, there's no point delivering it, or it's not legal, or it's unsafe, or it's not a viable solution. So anything that's marked down as a must-have requirement, really has to be delivered. If it's not delivered, the project, is a failure. So it's that important. There is another part of it called should have. It's important, but not vital, meaning it's really painful to leave it out. So it's something that's, you've really, it's kind of like 80% of the solution of a normal solution, and you really wouldn't want to leave it out. But you know what? If it needs to be released in 2 weeks' time and we won't get there, we'll scramble along and do without a should have. But normally, in any Agile solution, we're trying to deliver the must-haves and all the should-haves as well. And then there's the other things, which are the icing on the cake. So they're wanted or desirable, less important, but there's less impact if they're left out compared with a should-have. So this could be, the look and feel of the solution, how an MES solution looks on the screen, where things are placed, the coloring, the branding, where controls are located, what type of controls, drop-down boxes, all types of things, if you can imagine a HMI screen, how that's set out, could be something to do with a could have. So whilst it's, could look lovely and all those sorts of things, if it's functional in 2 weeks' time or 2 months' time, and we can start operating with it, well, we're happy with that, and we'll keep on going, and we might bring the could haves into another sprint or two down the track. And a sprint is obviously an Agile term where we work in short timeframes. So just apologies for people that are already working in Agile environments. This could be a little bit boring for you to have a listen to, but for those that aren't, it's necessary that I go through this. Now, the other thing is we also talk about won't haves. Now, that's really important in terms of like scoping out exactly what's not going to be delivered. And this is also as you can appreciate, a useful conversation to have. It's just not going to be delivered, but in the context of Agile, it means it's not going to be delivered in this time frame, meaning we might want to deliver it in a sprint, 3 or 4 weeks, or 3 or 4 sprints down the track, and normally sprints are a couple of weeks long. Or it might be not even the context of this project at all. But while we were brainstorming scope type items, we actually talked about them and agreed with the customer that we're not going to deliver this. As you can appreciate, it's really handy, to be very clear about what we're not delivering as well. It makes it easier for everybody to understand that. So in terms of the application that I was talking about, that we had developed, we were very clear on all of these things, the must, shoulds, and the coulds, and the won't haves. We gave those specifications to a software company that was working in an agile way and had been working, for the French government for many, many years. And so they were very mature in Agile, so they were quite happy to quote us based on all of these specifications that were written in an Agile way. And they delivered exactly on time. They also delivered, and we paid them exactly what the price was that they quoted. But the thing was, it's not a one-way street. So as an Agile customer, the expectation for me was to make sure that I reviewed everything that they'd come up with overnight every day, because they were overseas, and that I accepted or suggested changes every day and was involved in a stand-up meeting, even though it was virtual. It's another Agile term. Every day we get together for 15 minutes and review what's happened yesterday and what's happening the next day, and we move on in a collaborative way. So it's not a set and forget thing. If you're going to be an Agile customer, the expectation is that you're pretty much embedded in the team. All right, so here is a real specification that we're going to talk about today, and it's a very interesting one, and it is a real one. Not so much long ago, we were consulting for an electronics recycling company. So this may be a couple of years old now, maybe a few years old even. But what we were doing was we were trying to specify the realization of a glass crushing machine using Agile terminology. So this glass crushing machine is interesting from the point of view that electronic recyclers in Australia, and I'm sure in the US and over the globe as well, there would have been a big backlog, not so much anymore, but there was back then, of cathode ray tubes, the old TVs. So people getting rid of their old TVs and wanting to get rid of them in a safe environmental way, they would give it to this company. But really what would need to happen is that cathode ray tube would need to be crushed. And the reason why it needed to be crushed is because the glass, which was lead lined as well, was useful in terms of its sale. In this case, the glass was used for a lead smelter as a flux for the lead smelting process, and the lead smelter was actually paying for for the output from this recycling plant, and to have the glass crushed up to a certain size and delivered to them basically in crates and in pallets. So we had to have something to do that with, and the initial solution that we're using was basically for everyone to gown up head to toe and basically use hammers to crush it all up. So it's a very unsafe thing to do, very noisy, and we needed a solution. So that was taken away from people's hands, and they couldn't get injured from doing that. So really what I've got here over the next few slides is the way that this particular machine was specified. And really, and this slide here that I've got here is pretty much one of the first pages of the specification that was written to describe what we wanted. So, and here is a description of the requirements prioritization. So I'll read it out verbatim. So the method of requirements prioritization will use the Agile Moscow method of prioritization. The cost and time to deliver the detailed design shall be fixed and estimated to deliver all of the prioritized requirements. Now, what does that mean? That means that we look at the specification, and if we're estimating it, if we're the supplier, we estimate it to deliver everything that's on that list. And we'll talk a little bit why that's important in a minute. The designer, in collaboration with the users of the solution, will trade off on the could and should have priorities to remain within budget and time constraints. All must-have priorities must be delivered, or the design will be deemed unviable. So that's the important thing. You know, must-haves, we must not deliver them. Essentially, and following is a description of Moscow prioritization for the solution requirements. So there we go, not anything different than we had in one of the previous slides. All right, so if you can imagine, I'm the mechanical design engineer that I gave this specification to. They had never used or worked in an Agile environment before. However, we had worked with them as a supplier before, and they wanted to try and work in this Agile way as well because they could see the benefit of it. And so what they did was that they looked at all the specifications, and exactly as I said, they gave us a price and a time frame to complete the design for the glass crusher, based on delivering everything. But the trust between us and this mechanical design engineering house had been built up over many years. And that's one of the key things about being Agile customer and supplier relationship. It's normally very trusted relationships, because me as a customer, I'm going to be happy to trade off on something. And that means that they can, whilst everything may or may not be delivered, the supplier will still make a profit. And that's really important for both, that we can trade off a little bit about what we specified, but on the other hand, the fixed time and the fixed price stays on the supplier side. So it's a very trusting relationship that needs to be in place. All right, so I'm hoping you can read this, and if you can't, I'm sure that what I would do is make sure a copy of this presentation is available, so that could be sent out to anybody that would like it after we're finished. But here is some extracts of this particular real solution. So let's look at some really basic information that's been put in here. So there's a cycle description. So one complete cycle consists of loading a cathode ray tube, or a CRT, or a number of CRTs into a crushing chamber. The first crush of the CRTs is used to access a metal shield. So all of these CRTs had a metal shield inside of them, and generally they were bashed up with hammers, and then the shield was taken out and put in another bag, and then the final crush happened after that. So then we needed some manual intervention to remove the shield, and then a second and final crush of the CRT. So that's a really basic idea of the cycle and what needed to happen. So interestingly enough, you would see that there's been some business analysis done to produce these requirements. So every one of the IDs has got every one of the requirements, has an ID. And so if you can see on the left-hand side there, F means just basically a functional requirement. We can see that the source has been the users. So we asked the user, we actually went down to the factory floor and asked users about what they wanted. So there's some really interesting ways that you can specify based on using Agile techniques and Moscow prioritization. So you can see there the first one. So if you can imagine the manual process that used to be in place to crush these CRT tubes was via hammers. And so that cycle used to take around about 75 seconds to do one of them, which seems pretty quick, you know, but these guys and girls were pretty experienced about doing this. So you can see there that to completely crush one CRT glass through a horizontal grate in less than or equal to 75 seconds actually represented how long it took right now. So it was a must-have, you know, that if this machine, at its very least, needed to be able to do that in 75 seconds. Otherwise, why were we doing it? We weren't getting any advantage out of it. And while safety is really important, we wanted the cycle time to be better than it is. And so you see there that we've got a should have there. And the should have is to do it in less amount of time. And you see that this running through all of this specification is, you know, it'd be really nice if it, as a very minimum, it's got to do it in this amount of seconds or to meet the specification. But if it does it in less time or more efficient, then that's a should have. So you can just see that there's a trade-off there. There's a second one there. Two-step crush process. That's just a single one. Uses a two-step process so that following a preliminary crush, an operator can access the plant to remove the CRT metal screen to preceding the final crush. There's no ifs or buts about that one. It's just a single requirement that's a must-have. And then you can see there is another one which says, and this is using all three of them. So this is using a must, a should, and a could. So at the very least, this machine should do one CRT. And it really should do 3 CRTs. That would be, you know, a lot more desirable to, you know, to put 3 CRTs inside of this machine and have 3 done in one cycle. And it'd be really fantastic if it could do 5. But you know what? If it, at the end of the day, you know, in the time frame and for the budget that we've got, if it did just the 1 CRT, would accept that. To be clear on this one, this design ended up to be able to do 3 in one cycle, which was fantastic. Interesting enough, let's look at some of, without going through them one by one, because I think you might be getting the idea. But you can see there's some other interesting ones there. So this thing needed a base plate on it. And that base plate basically crushed, allowed just the glass that was of the right dimensions to fall through that base plate. So sometimes they had different specifications for the diameter or the size of the glass that the customers wanted. So we needed to be able to like change that along the way. So crushing base plate, allow for a removable crushing base plate. That was a must-have. And you can see there is the specification again, which is split up in must and shoulds, you know, in terms of like they change over time to do that. So allowing the base plate to be replaced, removed and replaced in 30 seconds was a must-have. So that's a pretty short, 30 minutes. So that's a relatively long amount of time, probably the same amount of time that it took them to do it manually, because really they just had a table with a base plate on there and they were just crushing through that base plate. And then as a should have, to let the base plate to be removed and replaced within 15 minutes, which was better. And so that was actually what happened. We did get that done within 15 minutes. Okay, so now we've just moved up into a bigger kind of slide, because we've removed the requirement ID, the source, and the requirement title as well. So for those that are CSIA certified, you know, this is what we would be using basically to line traceability up and to prove that we'd actually delivered what we said we were going to deliver. We would use this as evidence if you are going for certification. All right, let's have a look at a few more. So crush cycle time. So completely crush CRT glass through a horizontal gate in less than or equal to 75 seconds. That was a must-have. And to do that in 1 minute was a should-have. And you can see there what we talked about before as well. It's the being able to do 1, 3, or 5, and also utilising its 2-step process so the preliminary crush, an operator can access the plant to remove the CRT metal screen preceding a final crush. All right, let's have a look at some different ones now. We can see there is something called an NF, which is non-functional requirement, but it's interesting in terms of what the source is on that one. So you can see the source is legislative. So remember what I said earlier about a must-have. You know, if it's not legal, if it's a legislative requirement, it's a must-have. It really has to be in there. And obviously machine safety and electrical safety is one of those things that is really important. Okay. Now, so we can see their machine safety. Electrical, the solution will be safe from intrinsic electrical shock. Any control system will safeguard an operator from being physically injured. Clearly a must-have. Another mechanical one, the solution will prevent an operator from being physically injured. Another must-have. And electrical, and this is an Australian wiring standard, wired in accordance with AS 3000 wiring rules. So it must be actually do that as well. And we can see there's another interesting kind of specifications to operate from a standard 10 amp 3-pin plug. That was a could have. It'd be nice if it uses less energy that could just plug into the wall, you know, that you could basically plug a fridge into, or a bigger one, which is 15 amps, or the must-have was the, you know, the 3-phase outlet from the wall, which probably meant that was probably using a little bit more current. And there was actually, where we wanted to place this thing, there was quite a few of these outlets there. So it was a must-have that it did that as well. And also for ease of cleaning as well, we had some could have requirements around that as well. Okay, and we talked a little bit earlier about continuous operation. So operate continuously for 1 complete 8-hour shift per day. That was a must-have, but really it would be wonderful and expected really to be able to operate for 2 complete 8-hour shifts per day. As it turned out that this, in terms of the realization of this design, it ended up to be working on 3 shifts a day, because nowadays they crush different things in there as well, not only CRTs, because pretty much the market has been exhausted of cathode ray tubes now. So they use the machine for different reasons, but recycling is such a huge thing here now in Australia that organisation is now working 3 shifts over 6 days a week, given the amount of things that need to be recycled these days or are recyclable. So that's been a very good thing for them to be able to convert that machine over to something different than just CRTs. And we talked already about allowing for removable crushing base plate. So allowing the base plate to be removed as well in a cycle time as well. So I'm sure you're getting the gist of, you know, the advantages of being able to specify it in this way and the flexibility of being able to do it as well. So what happened out of this particular design? Well, the result was that the mechanical design was finished on time and it was finished on budget. And as I talked about before, the engineering company basically gave us a price based on delivering everything. The customer review and acceptance throughout the design process. So I generally was the customer, but also users at the factory floor as well. So every day when the mechanical engineering company would have a new idea of how this thing would look, how it would operate, doing all their CAD drawings, we would be expected to turn around that in a day, or to collaborate with them very quickly to make sure that the design engineer was always evolving the solution, which is a term that we use in Agile a lot. So every day that solution evolved, and every day we had a look at what had come up with the day before. And, the certainty of that is amazingly good, because we can see how the design is evolving, and the design engineer is absolutely sure that they're on the right track, and they haven't sort of spent 3 weeks designing something, taking it to a review meeting, and then suddenly we don't like it. It makes it very difficult to realize a design if you don't meet, or there's no review, constant review process. Is one of the beauties of working in an Agile way, is you can see the design evolving before your eyes, day by day by day. But of course, the trade-off is that you need to be pretty much embedded in their design team or their product development team, or somebody needs to be in there. That's normally a role called a product owner, and they're normally embedded in there to make sure that the design is evolving and meeting the requirements. So what happened as well? Obviously, we wouldn't have accepted it unless all the must-haves were met, and they certainly were. But 80% of the should-haves were, and 50% of the could-haves were as well. So we were very pleased with the result that we got. One of the important things that we do in an Agile sense is not only that we're involved with reviewing the design and accepting it along the way, or providing tweaks and changes in directions along the way, but we're also involved with having what's called a retrospective at the end of the design process, or at the end of the project, to iron out any lessons learned, and to see whether or not if we worked in this Agile way the next time, what things we could do better to, maybe evolve the design faster, to become more efficient, to make sure that to see if we could evolve to a point where we were like meeting, all of the requirements, not only, 50% of could haves, maybe increasing that to maybe 80% or even 100% of the should haves as well. So that's really important in an Agile sense. And sometimes when you're working in Agile teams, we're doing this in sprints. So we're evolving part of the specified part of the design every 2 weeks. And every time we finish a 2-week sprint, we're actually doing a retrospective sort of mid-project to see if we can do things better the next time we move into another sprint. So again, highly collaborative, very trustworthy relationship. The other great thing is that the designer's got the next job and the one after as well. So based on this trusting relationship that we got, we just kept on specifying different machines or upgrades to the current machine using Agile specifications. And of course, the beauty is that we've got a certainty of delivery in terms of the time that it takes to get the result that we want at a fixed price, but also because the supplier has quoted on delivering everything, and there's a little bit of wriggle room in meeting some of the requirements and not others, then the profit and the margin comes out of that flexibility that we've got in the relationship there. So it is a very different way of specifying. It is something that we're seeing more and more, and we see a lot more of our clients and even SIs interested in either using this type of thing internally to specify their own requirements that they're doing for customers if their customer's not ready, or having conversation with their own customers that have got current really trusted relationships with, to try and specify in this Agile way to get the benefits of both sides. Certainly in IT environments, this has been around for a long time, and there are like permanent Scrum teams that are working for, for argument's sake, a bank, the customer portal, is constantly getting revised and evolved, for release. Every couple of weeks, there is a supplier Scrum team working working to do that every couple of weeks, and they would be using must-haves, to get bugs out, to introduce new functionality, and also working with shoulds and coulds for other less vital functionality or non-functionals that need to be put in place, such as putting a patch on for cybersecurity or anything like that. So it is really something that, if you haven't seen it before, you will certainly start seeing it down the track. All right, so nobody has asked any questions so far, but that's pretty much what we're scoping today. That's all we're going to talk about, is just this Moscow way of specifying and the advantage out of that, and some real examples. So if there are any questions, I'm happy to take them now.
Looks like we have a quiet crowd today. Everybody understood your points. So if you let me conclude the event, I will do so, Tom. Can you stop sharing?
Sure.
Well, it looks like we do have a question from Eric Martin. And his question is, in your example project, there are phases to the level of design, and how long was the Scrum lasting?
Okay, for this case, it was just, we didn't use several Scrums. We basically, because we knew that the design could be completed within 3 weeks, and a sprint is normally set out to be 2 weeks, and maybe 3 weeks at a stretch. We decided that we would do 1 sprint, and the Scrum team met daily over that 3-week period to complete the design. So there's essentially just 1 sprint. But if the design phase was a long time, we would certainly break it up into sprints of possibly, the normal rule of thumb is that we use 2-week. We break our delivery up into 2-week timeframes and use 2 weeks at a time. So if it was like a 2-month project, we'd possibly have 4 sprints and a Scrum team working across those, finishing some part of the design and accepting it every 2 weeks.
Any other questions? We do have time. Okay, I think that was it. So on behalf of CSIA, I would like to thank Tom for this informative discussion, and especially for waking up at around 1 a.m. his local time. And finally, thank all the participants who attended this event today. We hope you found this event informational. We also like to remind you that a recording will be available for viewing within the next couple of days, so you may want to share that with your teams. Please visit the CSIA website to view this recording or a past virtual event you may have missed. Finally, be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. I will also provide here last-minute reminder that the CSIA estimation course is available. Remember, we have had more than 40 satisfied participants in it, and one of the feedback was that the examples that were provided were very realistic and system integration specific, so you may want to revisit that. We have the vanity URL, controlsys.org/win-more. Or if you forget, like I often do, you go into the search bar of our website and type in estimation training. You can contact Lisa or myself with any questions. If you would like to interact with us, happy to do so. Thanks, everybody. Have a great rest of the day.
Thank you, Jose.